so much more for, uh-oh, what's off?
What's that?
It's power off up there. They're on the edge.
That's why it was part of the can.
Sure.
What we learned last time was this,
Application, but,
that's it.
I don't even want to see that bucket of water until after we get a turbine running. There's no reason.
Bring up here tight so that you don't have any like
There you go.
No, I mean, the pipe is up tight. Good.
Yeah.
Yeah, and then bring this up so that it's short.
Yeah.
Cause this
So it doesn't fill up.
Yeah, right, and inflates kind of.
Yeah.
Get hot.
Good, We'll prop up that end. Boxy here.
You want to put the longer one back on there?
We don't want too long.
I know, I understand, but
think
I don't think
short-
I don't think we can get to the bucket thing today.
Really?
I think we're just gonna barely
Well, I
get
see
any.
it, okay.
Yeah, I don't see where.
That's your thought, okay.
We spend all of our time getting to the
Well, we
end
got a major flow
and
rate,
not
too.
get anything done to the middle.
Well, I hear that, yeah.
Okay, so okay, just about
Where's
ready.
that screwdriver, Jim?
I put it in the top drawer, top up there. This one?
Yeah, the one in the left, and the driver.
Brian's got it.
Oh, Brian's got it?
I
Okay.
don't have what.
Nut driver?
The nut driver. Here it is up here.
Oh, okay. Here it is. I was just holding on to this piece, so
Oh.
want to make sure I had
Yeah,
it.
you got it, yeah.
So we got the box, so we're good.
Yeah, and, Mark's getting that, getting this put together.
Dual input should be really nice.
I'll go put this back and get done with this.
Okay. And what about this gauge, Brian? Which is
We got to put the gauge on, but it's just gonna be put on. I don't know where it is.
I know you had it in his hand.
So I'll get this piping done, and that'll be done. And then we got, you want to put the transducer in? I mean, the thermocouple? Or it's in your way, so.
What's thermocouple?
This guy. This is
That goes right there? Oh.
screws right.
You need a pair of pliers, or?
Yeah, it just screws right in here. This is a low pressure zone, so it doesn't really matter.
Well, it does.
I believe we go to a high pressure, and I don't think we're ever gonna get there, really.
Well, my point is with the steam, to make sure it stays hot, you know.
This is some stuff.
Okay. Hey, we're getting close. So, where did Martin go to get the, do a couple of hoses?
Yeah. Machine, yeah. Here it is.
Okay. There we go. That's it.
Our dual input system. Here. So we got quick couplers there, we got quick couplers here. So you're going to want to take these two and put them on those little ends.
You mean the unions? That's what you're saying?
Yeah, the two union ends.
Yeah.
They're not just unions, they're
Super union.
is that what they're called? Super union? Right? It's called some kind of stupid union. I asked for a union, and the guy gave me a nipple, and I'm like, dude, I had to go to brass. I had to go to
I know this between a union and.
I know, but this is the guy over at Royal Brass, and he's kind of a pain in the butt. That's why they got him out there in the middle of nowhere. But you didn't, and I'm not taking it apart.
It's like you want.
Be all bad.
Oh, you know what? I don't like these. Yeah.
You're joking, right?
No, I'm serious because for some reason, where's the other hand?
Down here.
You ever had trouble getting at the seat right and seal? It's always a pain.
No,
Where's the pipe go?
We don't have.
Where's the pipe go? the bucket up, the little thing, I put, just put a little bit on there.
Oh, on the
We
face?
don't have any replacement, so
No, he's saying he doesn't wanna leak.
they won't leak.
Okay.
They're ready to like
They
1,000
do.
PSI. Will we deal with those lasers?
Here, I got this pretty good stuff.
Yeah, go for it.
This is the copper stuff, and
Right.
when we're ready to go, I'll put this on there, and it helps. It helps seed it.
Should I face them both up like this?
No, I face them.
On the
On
side.
an angle?
As long as it clears the,
Well, I'm getting pretty heavy on the angle here.
oh, you can't make it another
I
turnaround?
can't make a whole nother. That's about as far as I'm gonna get. Without, I don't wanna snap anything off. You're not interested in snapping. Snapping the old home. There you go, somebody's thinking. What, you're not thinking?
No.
You're reacting? Alright, let's blow that, give that back there.
Yeah, all right. Anything will make a cool cannon.
It's gonna be a cannon, we're gonna blast it. Thing out in the room.
Alright, one more turn and this one's done too.
Okay, I'll come back.
Alright, that's the angle that I'm willing to put down. My fridge. So, is this ready to go on?
I would put some tape on it.
I just wanna make sure it's the right size. There's your advice.
Okay, going back to.
Hey, Brian, RC's a funny bird.
He's a very funny bird. Just trying to help him. Otherwise,
Don't do
why
that.
do I care if he sells those stupid things?
Don't tell him.
Okay. So I'll need tape on, run out of tape. Oh, you put pipe dope on there, didn't you?
Yep.
Alright, so I'll just tighten all that down. I could have duplicated the audience 4 years ago and saved myself all the trouble. The whole point, I know. Well, no, we've got, there's other avenues that we have to try, but the whole point was to get rid of that
I
drag.
understand.
So every time he says the word drag, I just want to yank his head off and spit in his neck.
Don't worry about it.
Okay.
Keep going. It doesn't matter. The results are all that matter.
I understand. Oh,
The results will answer every question. So, perfect.
right afterwards.
Well, I'm curious what the short readings are gonna be.
I'm curious just if it fucking runs. If it runs, I will get a torque reading, that's a bonus day. If it runs.
I thought you ran it with the thinner
No,
design.
never ran.
Oh, you never ran it with the thinner
I
design?
don't know, man, all the energy was gone by the time.
No, I'm talking about when you were down in Morgan Hill.
Yeah, but we're not talking about that one, we're talking about this one.
No, but that one, you had it running.
Oh, yeah, right, you ran good.
Yeah. So this is, you know, so in theory, there's no issue why this one won't run.
Well, and the other one,
What's that wishing go to? One of the other, and,
that's seal for the shaft. Anyway, it was hooked directly, it was like right here. It was hooked right there, the turbine was hooked, there was no hoses, it was hooked right at the valve. So all I did was turned off the bleeder valve and turned on the turbine valve and but it was also 540 degrees steam.
why was it so high?
That efficiency of that cannon is just so massive that I got 540 degrees steam in a little teeny container this big, and it was massive amounts of steam because I preheated it with the coil, the exhaust. But the exhaust was also what drove the turbine. It's a great plan. We just gotta get the turbine done. So the system efficiency, yes, I thought about that for years. And that whole detonation cannon was part of the original equation.
We just need to get this.
We just need to get this done so I can move on. I'm tired of playing with this thing.
No, I'm not, I mean,
I know.
even for something's not that bad
I
necessarily.
don't understand it. So I need you to eventually say, Brian, let's move on to the next thing.
Well, yeah.
Well,
Well, we gotta see where we're at.
right.
I'm hoping we're somewhere.
Yeah. I know we're somewhere.
Yeah.
You're ready down this end, but again, just couple it up on both sides and we're ready to do a spin up test.
You got the morning road,
When did yours go for work?
grass crackers,
Yeah, we need all that. Especially if it works.
you rotate the hose a little bit before you tighten that down.
Which way?
Yeah, keep going, go. There you go. Just a little more, no more. There you go.
Wherever you want, right there.
Back, up. You.
You don't want that handle easy to get to?
No, cause it's okay. If the handle actually crops the gauge just so we can.
Whatever you want.
Kinda like a foot.
You are the man.
Okay, these are tight, right?
Yeah, everything's right.
So I'm gonna hook it up.
And if you're not, you'll need a little tighten. Okay.
I put the lubricant on the faces.
Yeah, I saw that.
Hello, Brian, speaking
Hard
out.
to getting it to center. And then
Yeah, I'm
once
in the
it
middle of
does-
the test at the university. We're getting ready to fire things up.
That's pretty.
It's pretty wet.
It's pretty close here, so that means all the threads are engaged. These things use all like 2 to 3 running airline.
Yeah. Yeah, the trick we do is put the coating on there.
On the face.
Yeah. It helps a lot.
And I'm trying to.
A lot more than it should.
I love you too, baby. Bye. Are we at a wrong angle or something?
Can you see it?
Yeah, you're gonna. Sure. Hi, Rich.
I was talking to the plant engineer just across the hall. I said, when you guys plan on shutting the steam off this building? He says, they don't. So we had a false understanding of when they turn the steam off, so they keep
Oh.
it.
It's more efficient to keep
So it's
on.
available, you know, we don't have a schedule.
All right, well, that's good to know.
Yeah.
Because I thought we were up against that schedule.
I know, he said, don't secure this team.
Yeah. Well, it made sense what he said, too, and what you heard. I mean, if you're trying to save money, then use a lot of energy to run boilers.
Yeah, well, they use the exhaust from a 2 megawatt gas turbines on campus.
Oh, really?
Yeah, this place is pretty amazing. Down this, you can't see from here, but they've got the buildings over there, gas turbine. And it
Hey,
combines
Jim, we're
heat
gonna
power.
crack
Natural
open
gas?
the gate now.
Yeah.
And they generate 2 megawatts. Just
Wow.
80% of the facility's energy needs.
Wow.
They generate. And then they have exhaust gas that goes to a boiler. And they have absorption cycle chillers that they use, the hot water. In the summertime, they have vapor compression chillers also, and they make ice. During the night, they make ice, and then they use it during the day.
Yeah.
You know, because it costs what they do have to buy some PG&E's lower at night.
Yeah,
So they got pretty good designed central plant.
they do.
Interesting facility.
It actually sounds, it surprises me that they're that up on the curve, you know, as far
Yeah,
as,
it's true.
you know,
It's been
I would've
there
thought.
10 years.
I'm sorry?
It's been there 10 years.
Well,
Maybe 8
I've
years.
been out to like Slack out by Stanford or whatever, and they waste energy and they do the craziest crap, they buy all their power. It's the biggest waste, there's no insulation or anything. and-
Yeah. Because the government's paying for
Oh,
it.
yeah.
Taxpayers.
More than I thought it was.
These guys, I was just talking to him, he's an engineer, plant engineer, he's working across
You
the
able to
hall.
get the gun?
I put my nose on it. They've got a couple big transformers. The load isn't what it's designed for. The building is designed for extra labs and waste fab, kind of operations here and expansion. It's got some big transformers that are way under loaded.
Oh, yeah.
So they're losing $20,000 a year from the core loss.
Yeah.
20,000. I said, if you take the transformer out of all the labor, how do you offset that? You know, he said, when you said 20K.
Yeah. It's worth
Big
it.
transformer.
Yeah. A lot of waste,
I know it.
especially on the
So they are
lower
trying
end
to
of the scale.
keep the costs down here.
Yep.
The energy, they do have an energy group right there. Plant facilities.
No, I mean, okay, Chris.
And they're talking about putting a big PV system in here. PPA. Somebody to install a big PV system. So they're energy conscious.
I see that.
And their, you know, budgets are getting squeezed, so that's one area that they're aware of.
Thermocoupler's not.
Energy is efficient, they can.
Yeah. Anyway, he said it's 15. No
Well,
problem.
that's great.
That's good, yeah.
Yeah, now that you've told me how they're doing it, that they're taking it off of a natural gas
That's right.
generator.
Turbine, yeah.
You know?
That's right.
So
It's not-
then
it's
the
just
exhaust.
waste power, waste energy.
Waste cogen, right?
Yeah, it's cogen.
Hey, guys.
Yeah.
So,
That's right.
no wonder they're not gonna shut it off.
Yeah.
I wouldn't shut it off. They're saving too much money not going to PG.
That's right, yeah. It's cogen.
Yeah, they're doing the ice storage and
That's
they're
right.
doing, you know, they're tackling everything.
Yeah. Yeah. Ready?
Technical issue. We lost power to the power strip.
You got me. Technical. And this light switch is on, so. You trace it back? Yes.
See that breaker right there?
Oh, geez.
And that one is 6E.
We don't have power nonetheless.
I can't get into these panels, I know.
They're locked?
Yeah. I tried before, but I can't get into the panels. You know, Gordon,
It's important.
we've got power strips around here.
All right, we're power ready for steam, I guess.
Yeah, that's a good chance for all the things.
Well, this valve is still closed.
I'm opening it slowly to get rid of
Okay,
the
okay, good.
As it slows down, that means it's turning directly to steam. What we're seeing is pressurization of the water.
Okay.
I got this part of control.
They don't know when it's going in yet, all right. Where you get the power strip?
You remember those 3 buckets of water that came out?
Yeah,
That's what we got to get rid of, is those 3 or 4 buckets of water.
I'll go across the hall and get one. Is there a place we can plug it in on the wall, right?
Yeah.
Yeah.
Get a power strip.
Maybe you just had the wrong plug, because, look, this
Keep
is
trying to plug.
light comes from the strip.
Okay, just keep trying to plug all the way up.
See?
Or did we not plug it in?
Hey, Tom,
Hold on.
this strip has power.
Oh, that's what happened. Never mind, I found a problem.
Alright.
We have a different problem. I found the problem. The gate came unplugged.
What?
Okay, we're almost seeing.
Gauge is what?
Came unplugged
Oh,
from its receptacle.
alright.
The old little receptacle.
Perfect.
Okay, so what goes here? Okay.
Yeah, that was the little one.
Plug this up into place before we get burned.
What? Oh, yeah. That's easy.
It took us 3 buckets to get rid of all the condensate.
We got it. We got it.
It does, it works fine.
Does it work now?
We gotta fix it.
Oh, okay.
That's what I said, we gotta, oh, I see. You ready?
What about the plastic? You want to put the plastic? The shield? No?
No,
Okay.
we're doing,
We're just gonna do a spell part test?
Well, no, we're doing a wet, we're just doing a wet test right now. Okay, I'm open here, you wanna open up
This
there?
is shut there, huh?
Yes.
Hold on.
So you're just gonna pressurize that hose.
I'm gonna pressurize the hose. Okay. All the way. Okay, you ready?
Not yet. Okay, let's let it pressure. 40. We're dripping out over here. That's okay, at least
Go
that's
right
where
drain.
it's going, that's where it's going.
Got it drained.
Okay, boom. Right to 100.
Yeah, it just popped.
Yeah, it did, then it came up.
Stem came up. So you wanna open the valve and do it,
Yeah, you want to do a concentrate.
Yeah, again.
well, if it does, it's just gonna push it out.
No, I know.
You need a plug.
Hold on.
But let it run for, well, hang on, let me get a bucket. Let's let it run for a while. Run the condensate out there.
There
I
you
hear
go.
another hole.
It's a long story, Phil, but it's stupid hole. There's gotta be a plug in or someplace, though.
Yeah, there is. You should.
Over there?
Yeah.
Alright, you're good. I'm so sorry about this stupid hole. I'm gonna reopen the condensate, let the thing bleed off the condensate.
Let me second, let's open this little plug.
Yeah, plug over there. You know it's gonna be hot, right? You want a glove? So you don't burn your hand?
Something happens, you go out that way. That's kind of.
Yeah.
Oh, did you shut it off or something? That valve?
No, never shut anything off. You're still
Still
in.
got pressure here, we still got 100
It's
PSI.
gonna take a few seconds to open that gate, so. I told you, be careful. That's probably a bad idea.
It's okay. Here.
I turned it off already, I got control over here.
Put these.
Hey, you're gonna solve yourself.
They're Willer's boots.
Hang on.
Oh, why'd you do that? Now it's hot.
What's that? Oh, I see where you plug. Playing about hot. Just gonna plug.
What are you doing? Okay, so turn it on? No.
Yeah.
Hey,
You're on there, right?
Yeah, but no, valve's off over here.
Close. Why don't you go ahead and open it?
Why don't we wait till he's done?
Okay. I mean, it's close here, but, that's fine.
Two
So
close
our-
is better than one.
Yeah, okay.
They just did it with Pike Pond.
Go for it, Brian.
That was pretty good, actually.
Ready?
Yeah.
So, wait a second, let's see this, that's really hot right there, wait a minute, turn it on, and I'll just control it from here, we got better control here. Control the valve?
This thing needs to be downstream of this.
No, that's your
So
water.
let's control it there, yeah.
Yeah, we control it right
So
here.
we want the inlet to the turbine measured here. With this valve, this pressure drop, we could try regulating with this valve, you know what I mean?
Okay, we can put that down later.
Yeah.
Downstream later.
Everything.
Ready?
Now, hold on, close that. I'll get this all the way open.
There you go. Good, we're spinning already.
Yeah.
Guys, we're spinning already.
Good, yeah, I saw that.
You wanna put,
Turn it off!
I bet I'm just blowing air.
Whoa.
Let's run a little bit longer, Brian.
No.
Let's let the steam go out that way, huh? What were you thinking?
No, we just locked up. He just locked up. You ready for this? We'll run it, if it locks up.
Okay, we want to do self-work, don't we? We don't want to run
I
it.
don't want to run it. I just want to run it, make sure we're spinning.
Okay, yeah, okay.
No, we did that. So I think we
So
still
we're
want
good.
to
I
run
hear
it.
you. You did a self-work test, yeah.
Ready? Yeah, we're ready. It's not running.
You said it's stalled, what do you mean? It's,
It froze the bearing because it got hot or something.
it did, it was spinning the whole time.
You didn't see it go slow down real fast? That wasn't me. I never touched it. It did it on its own.
Oh, I thought you,
I didn't touch it. That's why I was so surprised. Okay, you ready?
Let's turn on that something here.
That's probably a good idea.
Okay, so we can measure,
You ready?
so we're measuring the torque, right?
Yeah, right now.
Do you think it's safe place?
Much better than.
That's not gonna blow. Yeah, no, that'll blow, right? Pressure-wise,
You put the plexiglass
we
up
don't
there.
wanna get it to 100, we can't really get it in very easily. Plexiglass, the hose is coming out this way. So you're gonna wanna just get it up to like,
Your number.
80 PSI or something down here on this sheet, right?
You want me to turn it so you guys can look at it?
Start. 5-7. 0.57. Yeah,
What pressure?
Set it on the release valve.
Okay, 100 PSI, 0.57. So let's go to the torque, when it goes down to 80 PSI, read the torque at that point, do you think?
Yeah, you just watch the gauge go down.
Yeah, it'll go down naturally.
You got that? Turning it up.
To our,
Turning it up. And you got You just let that run outside. What's our exhaust pressure? Nothing?
So it's 95 at the gauge, 100 on this gauge.
we got pressure there, yeah, that's good. So that's about 5 PSI drop between the two spots.
Yeah.